Okay, so in previous videos, we've looked at, with time series, we've looked at types of trends, we've looked at plotting time series and making sure you've got a time code and all that sort of stuff. Now what we're going to look at is smoothing time series. So it's going to be about 4 videos. This first one's going to be a bit of introduction to the main types we're looking at, with a bit of a quick overview of what each of those ones does. Then I'm going to go through the 3 types in a bit more detail in subsequent videos. Okay, so part of it is, why do we smooth time series plots? So we can see, this is sort of this part here is a sort of a bit of a nice summary, but we've also got a nice summary down here. So let's just look. In cases where the pattern in the time series is random or cyclical, it can be smoothed using move-in median or move-in median smoothing, move-in mean or move-in median smoothing methods. Now, why do we want to do that? It sort of comes down to this part here. When a time series contains many fluctuations, it can be sometimes quite hard to identify an underlying trend. So we want to do this is we want to smooth the data so we can find what the trend of the data is without taking away, from the importance of the data. So we can use looking at means and looking at using medians, and we'll go through those in separate videos in a bit more detail. But here's an example of what some data, when somebody's looked at this data, So this is the original data, and we go with 3 mean smoothing. We can see it starts to smooth out. We can start to see a little bit more of the trend. Then we do the 5, which is the green one there. We can see that, there's the trend of the data. If it's got a slight upward positive secular trend there for my eyes. Yeah, so I'd probably say that. But it's sort of, you can see that. Whereas when you're looking at the blue, you can't. It's hard to really grasp that. So that's the reason, really, why you do smoothing. All right. So I've talked about mean and median smoothings. So when we do the move-in median, we actually do it graphically, and that's why I mentioned this one first. We do this one graphically, and I will show you that in a subsequent video what I actually mean by graphically. By moving mean, and then subsequently the sort of moving mean with centering, we have to calculate it. So the reason why we say this is a 3 and a 5 point moving mean, and so that's looking at when you're looking at sort of the odd number ones. You're looking at 3 data points at a time, and you get the mean from those 3 or 5 data points. And as we can see down here, the more data points you're using, the smoother it gets. But there's going to be a balance point where, if you did 9 mean smoothing, you're probably not going to get any useful information. And the centering. Centering is when we've got an even number value, where we're using a 2 point or a 4 point. And so that's that we need to center. And again, I'll talk about centering in the subsequent video. So here's basically a PowerPoint that I'm going to sort of look at. So why we smooth. So I've sort of talked about that already a little bit. It's about local fluctuations in time series. So we want to see an overall pattern, not the peaks and the troughs, and be going, what the hell does this mean? Okay. So it helps us look for those overall trends. We look at means and medians, as I've said before. So we can look at, this is an example here where we've got temperature. And so by having that there, you're sort of thinking, that might make an impact on what I'm actually trying to do. And if you do it by what's called 3 mean smoothing. Now I'm going to go into more detail on this in a subsequent video. But basically the idea is I'm getting these 3 numbers, get their means, and that's my value. Then I do it for the next 3 numbers, then the next 3, So when I say the next 3, I'm going, that's my first 3, that's my second 3, etc., etc. So it can get, if you're trying to write it out, it can get a little bit messy. And this is the value here that we're plotting, okay? So that's if you're doing a 3 mean. 5 mean is very similar. You're just looking at 5 numbers as opposed to 3. Okay, and we can see that, in this case, the graph's not changed a lot, but we've removed this sort of outlier part there, so we can get a better idea of what's actually going on with these temperatures. All right. Also note that if my data starts here, when I'm doing in this case a three mean smoothing, my data point starts there, and we'll go into that in the subsequent video why. 5, same basic idea, and you can see it's even flattened out more, so it's sort of, it's really taking out all the bumps that you might not be sure of what's going on. Okay, we want to use medians. Again, this is where we're using a graphical because we're looking at the values. We're looking for the median value on to do with this part here, and the median value to do with, when I go up. So that would be like the median value, and this would be the median value here. So that's a median. So they're going to go into some more details here to show an example. This is a very important point. So sometimes the point's not actually on the data point as shown like there, as shown like here. Okay, it's where, the value of that second one. So it's going to be this is the mean for here. These first 3 data points, I go up to here. All right. Then I'm looking at the median value here. This is the median value here. But that's at that height. So I'm just looking at that where those 2 values intersect, and they intersect here. Then if I did the subsequent one, I'd be looking at these 3 values. Okay, so this would be the middle number here. So it's like I'm going to go dot, 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 straight up. What's my middle value? I would almost say, it's a bit hard to see there. I would almost say that one there, and dot, 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 and that's where my next value would be, just roughly. Okay, so that's what we mean by, in this case, a median smoothing. And as you can see, it's smoothed the data out again as well. As you can see here, median smoothing smooths out the effect of one exceptionally hot day more quickly than the mean smoothing, because remember, between the 3 and the 5, it took to 5. Because it's more strongly by exceptional values. And we can keep doing that. We can do a 5 median smoothing if we wanted to. Here's if we did a 5, okay? So that is basically smoothing, the why we use it, and a quick overview of a couple of the different types of smoothing we've got involved. Like I said, the next 3 videos will be on each type. Okay, thank you.